Okay, solving rational equations. We're gonna end this class now with this video. You see, still got my roses bow tie on. And these are the notes that we left off with just a few minutes ago. Solving a linear equation, solving a quadratic equation. Quadratic formula is probably going to show up here in just a second. Hint, hint. I don't know what should I do with this. I'll just leave me over here for a second. I don't want to get rid of me yet. So from solving equations to solving rational equations. Equations with fractions. Equations that have rational expressions. So like in example 1, you have 3/4. That's just a normal looking fraction. Nothing too scary about that one. But the x over 20 might be kind of like, it's got a variable. Well, that's what we want to solve for, right? We want to solve for that variable. Like a lot of equations, number 1 here, you could probably just maybe make a guess because, you have some number sense, maybe. And when I'm talking about you have some number sense, maybe I'm not talking about you. Maybe I'm talking about, the guy next to you or the girl who like sits in the middle of the front row because she's annoyed by all you morons and she gets everything right. And you're like, oh, I didn't know. So you guys all have different capabilities in number sense. And number 1 is one of my favorite rational equations. I've been doing this one for like years. If 3 out of 4 dentists choose crest, then how many dentists out of 20 choose crest? And 3/4 is a pretty nice fraction, so maybe you've already got it. In geometry, you would have like similar shapes, similar triangles. And you would do side 3 corresponds to side 4 as side x is to side 20. Same problem, right? You set up a proportion. So when a fraction equals a fraction, it's called a proportion. It's still a rational equation. There's an equal sign in the middle and you have fractions. So it's rational equation, fractions and equal sign. A lot of times with rational equations of this nature, of when we have proportions, there's a certain other phrase that gets used for solving them, like when you had the geometry with the triangles, the similarity. In this case, 3 out of 4 dentists choose crest. So how many dentists out of 20 choose crest? And you do what's called what? Well, what is it called? You multiply the 3 times the 20, 60. You multiply the 4 times the x, 4x. And to solve for x, what do you do to get rid of the timesing by 4? You divide by 4. So x equals 15, right? And we cross multiplied, okay? Cross multiply, it's a good phrase to use. The problem is sometimes people cross multiply when you're not supposed to, okay? So you'd be very careful with cross multiply. It only works when you have a fraction equals a fraction. If the two fractions are equal, you can cross multiply every time. But if you have other terms or other expressions, then you don't want to cross multiply. Okay, you would get it wrong. So we'll see some examples of that in a second. But I made example 2 over here, another cross multiply with more variables. Because number 1, you might have figured that out on your own. You were like, bro, I got 75% all day. 15 is 75% of 20. So 4 times 5 is 20, then 3 times 5 makes 15. Number 1, you could have figured that out a few ways. So example 2, let's look at a different proportion where you got a lot more variables and a lot more math is going to happen. And I made this one up on purpose, or I copied it off your worksheet. I'm going to give you a worksheet attached to this assignment, and I picked some problems off of that worksheet already that I'm working on here, and some I made up. If you cross multiply, right, what is 2x minus 3 times x plus 4? That would mean 2x minus 3 times x plus 4 equals 3x times x plus 2. Oh, 3x times x plus 3. If I cross multiply, first step, and if you're one that's like down with the cross multiply, you've got cross multiply under your belt, you understand cross multiply, then there will be some of that here which will help you. Unfortunately, not everything's going to be cross multiply. This cross multiply is a little more exciting because look, now I have to multiply a binomial times a binomial. And when one binomial is being multiplied by another binomial, what happens? Foiled again. Foil, right? So basically it's distributive property. We've talked a little bit about FOIL on all these videos, or at least I've talked about it, and you guys maybe sat and listened. But still, you're distributing, right? What is 2x times x? The first 2x times x is 2x squared, right? And then the outside is 2x times 4, which is 8x. So I'm distributing 2x times both things in the other polynomial. And then you have negative 3x, the inside. And then negative 3 times 4, negative 12, equals 3x squared plus 9x. So the first step is doing all that distributive property stuff after you cross multiply. And what is 2x times x? It's 2x squared. Bad, Mr. Quirk. I think I said 2x squared, but as I looked back, I didn't write it. All apologies. So now, what would you do? Well, you combine like terms. And here you might notice, well, this is a different flavor than problem 1. See, problem 1, we cross multiplied, and we have 4x equals 60, which makes it which kind of equation? Huh? See, 4x is x to the first power, which is like our example 1 up here, which was linear. It's almost like I'm modeling our next two problems off of these two problems. X squared makes it quadratic, right? So with a quadratic equation, you have to move everything to one side, right? All of the terms get put together on one side of the equation so that it's equal to 0. That's your first step with a quadratic. So the way you solve problem 2 is very different than 1, right? And they're both rational equations. They're actually both even proportions. We cross multiplied on both, but I'm left with a linear function on one, which is way simpler than the quadratic. And when I look at a quadratic equation like this example 2 here, what I would do is take the smaller x squared and subtract it to the other side so that you get a positive x squared. So there's a 2x squared and a 3x squared. I would do 3 minus 2, right? So I'm going to minus the 2x squared, minus 2x squared. That leaves me with an x squared. And hey, look, there's an 8 minus a 3, which makes 5x. So I'm going to minus 5x to the other side. And 9 minus 5 makes 4x. And then there's this like minus 12. And how do you move a negative number to the other side? As you plus it. Plus 12 to the other side. And so that would equal 0, because I've moved everything from the left side of the equation over to the right. Kind of like if you take all the dirty clothes off of your floor, pile them up and throw them in the basement. There are now 0 dirty clothes in your room, right? They're all down on one other side of the house, right? Down in the laundry room. So that's constantly happening in my house with all the Quirk babies. There's laundry everywhere, you never finish the laundry. Never. Always dirty laundry. Now, this is a quadratic equation, and the one that we solved up above, example 2 up here, is different than example 2 down here. Because the previous example, we could think about numbers that multiplied and added. Here, can you think of two numbers that multiply to 12? Okay, well, there's 1 times 12. There's 2 times 6. There's 3 times 4. Do any of those pairs of numbers add or subtract to get you positive 4x in the middle, right? So this is our factoring part. I'm trying to factor it. Well, this isn't factorable. And if I had made the 12 a negative, I could factor it. Because 6 minus 2 is positive 4, and 6 times negative 2 is negative 12. If I had made the 4x a negative, then it would factor into... No, I'm not sure. If I'd made the 12 negative, it would have worked out better. But it didn't happen. So what I did this on purpose. I wanted to use quadratic formula. Okay, here. And the quadratic formula, can I write it right there? It's just behind the picture. Get out of the way, Mr. Quirk. Quadratic formula. We will use this a lot. And it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, normally with the quadratic formula, I write if ax squared plus bx plus c is equal to 0. So the a and the b and the c are the coefficients of the equation. If you have ax squared plus bx plus c equals 0, I normally write that and then I didn't. Quadratic Formula. I guess since this is the first time we're doing quadratic formula, I should do it. If ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll solve the equation for x. See how it says x equals. Now the tricky thing is there's two answers here because it's plus or minus. And there's a square root, which is kind of scary because square roots. You've all seen this before. If you've forgotten it, you gotta memorize it. It's a thing. You'll need it. You might be stuck on a deserted island someday, and a little bottle washes ashore with a note inside, and the note says, "If you write the quadratic formula in the sand, with a stick, we will pick you up in a helicopter." And you're like, "Oh, yes!" And then you're like, "Wait, what was it?" "Oh yeah, Mr. Quirk said it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I wish we were in class. It's way more fun to make all of us sing it together. But then you're rescued, It saves your life. Saves your life. When am I ever going to use this? You're going to use this when you want to save your life. So, for this problem, I'm tired of the blue. Let's pick a new color for the answer. X equals negative 4 plus or minus the square root of 16 minus 4 times 1 times 12 all over 2 times 1. And we do have a radical. And underneath that radical, for this particular problem, we have 16 minus 48. And what is 16 minus 48? 16 minus 48 is negative 32. 8 minus 6 is 2. And 4 minus 1, 3. Okay. Whole nother world happened here. We have a negative under the radical, and this is called an imaginary number. Again, these are things you should all remember from Algebra 2. I'm trying to remind you of things and teach you new stuff all at the same time. Genius, For our situation here today and now with rational equations, okay, none of these answers, look at this big hair I'm getting. None of these answers will be imaginary. Okay, in this chapter of the book, they're just like, let's not even pretend like we knew about that. Although you do know about that because quadratics was like chapter 5 and this is like chapter 9 in the book. Okay. But in chapter 9, if you get an imaginary answer, then you just say no solution. There is no answer. This equation has no answer for x that makes the equation true. The equation at the very top, we cross multiply. You can pick any number you want for x. It will not be true. It does work for two imaginary numbers, and the imaginary numbers are down before. And this point of this lesson is not to talk about imaginaries. We'll review those. We actually, in our book that we will use, there's a whole chapter with imaginary numbers, a couple sections of imaginary numbers. Okay, complex numbers. So it'll be a review from what you did last year. You've seen that before, but maybe you forgot. So for us on problem 2, we say no solution. No solution. And there it went. Daggone it. I was so happy. It was working so good. And I was like, please, can't stop, won't stop, don't stop. You know what I'm saying? Because you can't, you won't, and you don't stop. And when you can't, you won't, and you don't stop. Can't, you won't, and you don't stop. Beastie Boys keep rocking the shore shot. I don't know the rest of the words of that one. Dang, what were we doing? We were solving rational equations? Is that it? Yes, cool. I was writing no solution when it timed out. So we have a few more equations to get through. I think I have like 5. And I got through 2 of them and the thing died. So this is going to be a fun day, huh? So let's look at that there. Okay, we can see examples 1, 2, and 3 here. I'm going to move me up this way. You see example 1, we cross multiplied. Example 2, we cross multiplied. Look at example 3. This is not set up for cross multiply. If you compare problem 3 to 1 and 2, there are not two fractions. You do not have a fraction equals a fraction, okay? You have three fractions because it's 3 over x plus 7 equals 5 over x. And there's a few different ways to go about doing this. I could combine some like terms and make it a proportion, and then I could cross multiply, okay? And that's not wrong. But technically, what I want to talk to you all about when it comes to solving rational equations, the one thing that always works, whether you call it cross multiply or not, is what you really want to do when you have fractions is to get rid of the fractions. Eliminate the fractions, okay? You want to make them not fractions. So going back to like problem 1, right? Remember, we cross multiplied, and that step right there, 60 equals 4x in equation 1, example 1. That's no longer a fraction, right? 60 equals 4x is a linear equation. It's not a rational equation anymore, right? And then I just divide by 4. Same thing on 2. After I cross multiply, I end up with a quadratic equation, not a rational equation, right? And then I use the quadratic formula, or I factor to solve the quadratic equation on problem 2. So when it comes to solving rational equations, what you really want to do is eliminate the fractions. And how do you do that is you use the common denominator, okay? And ideally, you use the least common denominator. That's what happened on 2. On number 4, when I cross multiplied, I actually didn't use the least common denominator. I used a bigger denominator. I used 20. I used 20. Or actually, I used 60, because 4 times 20 is 60. I want to use 20. That's a whole other story. I don't remember that. What I'm getting at is just do the problem, Mr. Burke. When you have fractions, this is my recommendation to you, okay? This is what's going to be new and different. Because it used to be with common denominators, you multiply the top and the bottom by something, okay? You multiply the top and the bottom by the same thing, and that made your denominators the same, and you could add them. So we're in a different party now, right? We're playing a different game. So like in soccer, you kick the ball with your foots. If you need to throw it in, you can pick it up with your hands. If you're the goalie, you can pick it up with your hands, right? But the goalie can only run so far with the ball in their hand, right? The goalie can't go outside the goal box, or then it's a handball on the goalie. Man, in football, you can pick up the ball and run with it all the way across the field, right? We only kick it in football at certain times, right? We kick it like for an extra point or for a field goal, or if we need to, punt it or kick off the game, or after a goal. Okay, we're getting details now. I'm trying to say is solving rational equations isn't quite the same as getting common denominators and adding fractions together, but we're going to use the common denominator. So what I'm getting at is, let's scroll up. Stay here and move me back over there. When you see problem 3, my recommendation to you is look at that first fraction. Ask yourself, what would I multiply 3 divided by x by to get rid of the fraction? What is the denominator of 3 divided by x? That's basically what you do. So I'm going to multiply this first fraction. I'm going to multiply it by x. Right? I'm multiplying the fraction by the denominator that it has. I'm not multiplying by like x over x. This is a little bit of confusion that happens here because sometimes people, from after we spent like last week adding fractions, and you'd multiply by x plus 2 over x plus 2, right? Or 3x over 3x. You'd multiply by the same thing on the top and the bottom. You don't have to do that now. You want to eliminate the fraction. You want to cancel out the denominator. So what would you multiply 3 over x by to remove the denominators? You'd multiply it by x, which means then you also have to multiply the 7 by x, which means you also have to multiply 5 over x by x. I'm going to multiply each fraction by x. Why that? Because it's an equation. See, with an equation, you can multiply every single term in the equation by a number, and that's cool, right? It doesn't change the value of the equation. It keeps it the same identity, right? So it's the rule is you do unto one side as you do unto the other, right? As long as I minus 13 and minus 13 on both sides, my equation still works. If I divide by 7 and divide by 7 on both sides, the equation still works. Okay. If I times by x, times by x, times by x on both sides, the equation works. So here, I times it by x twice on the left side, and I times it by x once, because those are all the terms that there are. But I'm still timesing both sides of the equation by x. So notice the magic that happens now is the x over x cancels out. In the first term, you just have 3. Plus, the middle term, you have 7 times x, which is 7x. And then the last term is 5 times x divided by x. Well, those x's cancel out. You just get 5. Right? Because 5x over x is just 5. 3x over x is just 3. So now I've ended up with a linear equation. 5 minus 3 is 2. Divide both sides by 7. The inverse of addition is subtraction. The inverse of multiplication is division. So my answer is this fraction, 2/7. Okay. And notice what I did was I just multiplied each term by the denominator. Now, the miracle here was there were only 2 fractions in this equation, and they had the same denominator, right? That was a common denominator. X is the common denominator. The 7 is really 7 over 1, right? So the 1 doesn't affect the denominator. A factor of 1 doesn't change anything. So if I multiply the whole equation through by an x, I'm left with an equation that's no longer a fraction. So notice I did not multiply by x over x, and this is a different thing. This is tricky, because last week you would change the top and the bottom, and that's because you didn't have equations last week. Last week we had expressions, and when you want to add one fraction to another fraction, right? You want to add these expressions, you have to have the same denominator, which means changing both. But if there's an equals sign in the middle, right? If it's equals in the middle, you can multiply everything by one thing and eliminate the denominators. Reduce fractions to being not fractions. So, how many more I got? 4, 5, 6. All right, 3 more. Let's try to do this. I put these really close together. Separate them there. So, like, look at problem 4. I made it very similar, but I made it more fun because 1, 713, 713, 74. Whoop, whoop. I turned 46. Can you believe it? Look at this. Do I look 46? Anyway, ask yourself, what would I multiply 7 divided by x by to cancel out the x? Is you'd multiply it by x. The thing is, you're not allowed to multiply the first fraction by x unless you multiply the next one by x as well. And you're not allowed to multiply those 2 by x as long as you multiply the third one by x as well. Everything gets a factor of x times x times x times x. I'm basically putting a big fat parentheses around the whole equation and putting an x out front. And when I was in high school, that's what my math teacher would do. He would just multiply everything by x. And I found when I became a teacher that some students would mess that up. So I just write the x one time in every single factor. Okay, now go through and simplify. Okay, and what happens here is the 7x divided by x cancels out, and you're left with 7. Plus, notice what happens here is I have 13 times x over x plus 2. Because this x that I'm multiplying by does not cancel out the x plus 2. Okay, you cannot cancel this x with this x. They are different factors, right? The x factor is a different show than the x plus 2 factor, right? I really like the show X Factor. It's pretty cool. Oh yeah, you got to check out X plus 2 factor. It's a different factor. It's a different creature. It's a different name. If you let X be, 7, what does X equal? X equals 7. But what's X plus 2? 7 plus 2 is 9. 7 and 9 are different factors. They're different completely. So you cannot cancel this X right here with this X down here. They don't cancel each other out. Okay. So my middle fraction is still a fraction, okay? Now the last one, I have 74 times x divided by x. And just out of the kindness of the creator of the equation, right? Whoever that was. These x's magically also happen to cancel, right? That doesn't necessarily have to happen, but it did happen, right? I was able to cancel out 2 of my 3 fractions because they had the same factor in the denominator, right? So now looking at this equation, it's still a rational equation. It still has a big fraction in it. Hello, I'm a fraction in the middle of your equation. So at this point, you ask yourself, what would I want to multiply 13x divided by x plus 2? What would I want to multiply that by to cancel out the x plus 2? If you want the x plus 2 to go away, you would want an x plus 2 on top. Okay, this is completely different than what we did when we were adding fractions, right? You would do the top and the bottom. We don't have to do that now. I'm just going to multiply the top by x plus 2 because that is going to cancel out the denominator's x plus 2. Magic! The thing is, you're going, whoa, Mr. Quirk, slow down, right? You can't just multiply the middle term by x plus 2. What else do you have to multiply by x plus 2? The 7 and the 74, right? Every single term in the equation gets multiplied by x plus 2, multiplied by x plus 2, multiplied by x plus 2, multiplied by x plus 2. Every term. Do unto one side as you do unto the other, right? To keep the equation balanced, to keep it equal, you do the same thing across the board. Okay. Now I get to do some distributive property, right? Pick a new color. What's 7 times x? 7x. What's 7 times 2? 14. What is 13x times x plus 2 over x plus 2? Well, the x plus 2 cancels the x plus 2. And what's left is just 13x. And that will equal 74 times x is 74x. And 74 times 2 is what, 148? Because 70 and 70 is 140. And 4 times 2 is 8. 148. 713, 74. Woo! 713. Harrison Rogers. I got you, dog. I look at all the birthdays before we even start school. I do. And last year was Zach Bird. Zach Bird, me. We're birthday buddies. Or birthday bros. It basically makes us like brothers. Okay? Like half step brother-in-law kind of relation. It's almost like being, like cousins, but like with no one in the family being related to each other. And that's me and Harrison Rogers. Right now, Harrison Rogers is like, dude, please quit my name. Like, I don't even know you. For real. But anyway, happy birthday. Everyone has a birthday. I just hadn't realized that. Now I can combine like terms and solve regs. I know y'all be like, Quirk, can you just finish this problem? It would take forever. So 7x plus 13x, 20x plus 14 equals 74x plus 148. What I might do here is subtract 20. I get 54x. And then subtract 148 to the other side. So that's what, 134? Because 8 minus 4 is 4, and 14 minus 1 is 13, and you make it negative. And then how do you get rid of timesing? What is the inverse of multiplication? That would be division. So x is negative 134 over 54. And at this point, you want to simplify the fraction, right? And you might go, oh, we can cancel out the 4s. No, we can't do that. Undo that. Now they are both even. If I divide both numbers by 2, I get, 6, 7, and 27. And you can cancel out the 7s, right? No, can't do that. So 67 and 27 don't have any common factors now, right? The fraction doesn't reduce anymore. Took out common factors. So simplifying your answer is always a big deal. You should always simplify your answer. Okay, cool. Look, 5 and 6 have to get a little bit more fun. I'm trying to go fast because as right now, you probably see the clock at the bottom. It's 1:38, 1:18. I have class at 1:30 with fourth period. Right now, it's my planning. I have third period planning. So from 12:30 to 1:30, I can make videos. Lucky for you guys, right? Number 5. What you've got to notice, because it will make your life so much better. You've got to notice that denominator factors. This is 10 over x plus 1 times x minus 1. You must factor that denominator. If you don't, and you multiply everything through by an x plus 1, and then you multiply everything through by an x squared plus 1, you will have multiplied by an x cubed in total, which would give you a much bigger equation that you might then go, I don't know how to solve this. You want to multiply through by the least common denominator. You down with LCD? Yeah, you know me. Right? Least common denominator. How do you know what the least common denominator is? You want to first see all the factors. So this is like having a fraction with a denominator of, like, say 2, and this is a denominator of 1, and this would be like a denominator of, say, 6, right? See, 2 is a factor of 6. X plus 1 is a factor of x squared minus 1. So this x squared minus 1, it already has an x plus 1 factor, okay? So what that means is you don't want to multiply by an extra x plus 1. And what I mean by that is if you were to multiply by x plus 1 and x squared minus 1, if you multiplied by both denominators across the whole board, you would get extra factors and make the equation harder. So take them one at a time. But what you've got to do first, before the first step, step 0, is factor everything. Factor all of your denominators. I didn't have to do that on problem 4 and problem 3, right? Everything was already factored. I didn't have these extra factors like I do on 5 and we do on 6. So notice on 5, factor the x squared minus 1. You have to look for those factors of the denominator first, okay? Now go through and multiply by each denominator one at a time, okay? Start with, and let's pick green because we don't have that up here. I'm going to multiply the first fraction by x plus 1, which means I multiply the second fraction by x plus 1, which means I multiply the third fraction by x plus 1. I do x plus 1, x plus 1, x plus 1. Every single term gets an x plus 1 factor, okay? Notice the middle fraction, I made it a 1 over 1. So if you ever have like a number or a variable like plus x, I would make it x over 1. That way you know the denominator is a 1. If the denominator is a 1, life is good. So that's what I'm trying to do, is I'm trying to make all the denominators 1. I'm trying to get rid of the x plus 1 denominator. I multiplied by x plus 1 and it cancels out the x plus 1. And by magic, notice that also happens on the last fraction. The x plus 1 cancels out the factor of x plus 1. So if you don't factor that last denominator, you might not know that it cancels out. The x plus 1 cancels out. So let's go back to green and see what's left over. What's left over is I have 5 plus, what's 1 times x plus 1? Well, that's x plus 1. Right? This is 5 over 1 now. X plus 1 over 1 now equals, and what's left here is I have back 10 over x minus 1. I'm keeping that the original, color, so it hasn't changed. So now I want the denominators to all be a 1. So what do I got to multiply by? I got to multiply this 10 over x minus 1 by an x minus 1. Okay, what does that mean? It means you got to multiply everything by an x minus 1. X minus 1. March of x minus 1. Now, on the other side of the equation, you might go, well, isn't that just x plus 6? It is an x plus 6. And you can do the x plus 6 times x minus 1 in FOIL, or you could just multiply every single thing by x minus 1, right? Like I can multiply the 1 by an x minus 1, the x by an x minus 1, and the 5 by an x minus 1. Or I could combine all of these together and multiply by x minus 1. Or I could put an x minus 1 by each thing. This is x minus 1, this is x minus 1, this is x minus 1. Remember, these technically are all over 1. I don't really have denominators, right? So what I'm going to do is multiply each term by x minus 1, x minus 1, x minus 1, x. Each thing gets an x minus 1. It's all the same. I could do this like 3 different ways, write it out 3 different ways, it will work. So what's left now is I have 5 times x, which is 5x, minus 5 times 1 is minus 5. Plus, I have x times x, which is x squared. And I have an x times a negative 1, which is negative x. And then I have a 1 times x, which is x. And then I have a 1 times negative 1, which is negative 1, equals 10. Oh, whoa, and it's negative 10. Bad Marty. Negative 10. Again, it equals negative 10. Back in purple, negative 10. There was a negative at the very beginning. Holy moly, 124. This is tough. Take a breath. So I have x squared. 5x minus x plus x is plus 5x. And then I have a negative 5 and negative 1, which makes negative 6. But then you're going to add this negative 10 to the other side. So what's 10 minus 6? 10 minus 6 is 4. Almost like I set this one up perfectly, right? Because can you think of two numbers that multiply to give you 4? Well, x is obviously x squared. And duh, 2 times 2 is 4, Mr. Quirk, you moron. And what is 2 plus 2? 2 plus 2 does not make 5, right? So this problem doesn't factor with a 2 and a 2. It factors with what's another way to multiply two numbers to get 4? 1 times 4, right? So 1 and 4 are my two factors, x plus 1, x plus 4. Whew. Now, what are my answers? This is where we make our mini equations. And when I was doing this in class today, you couldn't see me go mini equations. But if you need to set up your mini equations, you have x plus 1 equals 0, and you have x plus 4 equals 0. You take each factor and set each factor equal to 0. You have two mini equations. Okay, you solve each mini equation by getting x alone. So how do you get rid of plus 1? You subtract 1. So 0 minus 1 is negative 1. Oh my god. And you subtract 4. And 0 minus 4 is negative 4. Perfect timing for this, by the way. No, not that. No, 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 no. No. $125. I'm going to do it. I'm still going to work out this last problem. I know you were unable to connect. Duh. Lecture notes. Go away. Okay, you see our two equations, a big deal. I did this on purpose. Because remember in middle school, when you first solved the equation, your teacher would say, and I know if y'all had Miss Elby, I know you did this for like pages of math because my daughter had Miss Elby and my sons had Miss Elby as well, but I don't think they worked as hard as Mary did. Miss Elby would always say you have to check your solution, right? You have to take your answer and plug it back into the original equation. And if you're like Mary Quirk, then you did that and you had like all this extra math. Which, if you look, we've done a ton of math. Like this problem took 45 minutes and it's like 10 feet long of math. The last thing you want to do is check your answer. And I'm not asking you to do a whole bunch of algebra, but there is something true about checking your answer now that wasn't true in middle school. See, in middle school, if you did the problem right and you checked your answer, it was going to be right. It would work. And that's why I was kind of just happy to get my answer and not check it. Here, you have to make sure that your answer doesn't ever give you 0 in the denominator. If you get 0 in the denominator, because see, this equation, we made it quadratic. It didn't start out quadratic, right? It started out a rational equation. Where's my finger? It is a fraction. And then we turned it into a quadratic after we did the common denominator thing. Now I got two answers. It's possible that one of those answers doesn't work. It's possible that both answers don't work. It's possible that they both do work. But you'll notice the issue here is the negative 1. X equals negative 1 doesn't work. Because if you go back to the top and plug negative 1 into the denominator, what is negative 1 plus 1? That makes 0. And 5 over 0 can't happen. Negative 4 is okay. The answer is negative 4. Only negative 4. So these directions on the worksheet ask you to check your solution, and you should do that, or else you'll have a boo-boo. Okay, it's 128. Notice this problem. It's the numbers are not so bad, but what is true about it is, of course, the second half, the right half factors, right? The right half factors into x plus 5 and x minus 2. This is so exciting. It's like 128. I have to start class in 2 minutes. I don't even have my notes brought up for my fourth period class right now. This is thrilling. See this how this fraction factors. So when you look at this equation, there are not three different denominators really. One of your denominator is comprised of the other two. So if I were to multiply through by x plus 5, right? X plus 5 x plus 5. The x plus 5's cancel. Nope. Heck on it. X plus 5's cancel. What else do I need to multiply through by? I also need to multiply by an x minus 2, because the x minus 2 would cancel there. If I multiply by x minus 2 in the middle, it cancels there. Then I got to multiply this last 10 by an x minus 2. So the least common denominator is x plus 5 times x minus 2, or x squared plus 3x minus 10. So what's left over now if I would go back and write down, let's use purple. Oh, geez, Martin, what in the world are you doing? It's 10 times x minus 2 minus 7 times x plus 5. And that would just equal 2. Good! 130, gotta go. This is funny. This is actually really difficult doing math this way. I don't feel like I'm doing a very good job, but oh well, what you gonna do? What you gonna do when it gumbo you? So now I have an equation that works out pretty nice, right? I distribute the 10. I got 10x minus 20 minus 7x minus 35 equals 2. I'm wondering if I write really, really fast, if it will work. And what is 20 plus 35? 55. You add that to the other side. 2 plus 55 is what? 57. And 3 goes into 57, what, one time? 19 times? Are you serious? It didn't write the final answer. So you finish it. Finish this equation. You should get 19, because I got to go to class now. It's 1:30. All right, Julio, rational equations. Have fun. See you Thursday.